So whenever we discuss about statics, okay, like it or not, you have to draw free body diagram. And drawing free body diagram is not just drawing whatever you like that. Okay, you have to know what's the problem that you have to solve, and then draw the free body diagram based on the problem that you have to solve. You have to know how to isolate the free body diagram. Okay, for example, yesterday we discussed about this, right? Okay, we isolate the beam from the rest of the system. That's why what we draw in the free body diagram is only the beam. We do not draw the constraint, okay, the pin joint. We do not draw the pin joint. We do not draw the roller joint. We do not draw that. But what we draw is only the beam, because that's the problem that we need to solve. Okay. For this particular example, we discussed about it as well. Okay. We need to solve this problem step by step. First, we have to know about the tension between the 30 kilogram mass with point D, and then we need to find out the tension CD from the pulley D, and then after that we solve for the ring, the equilibrium at the ring, like that, in order to solve for FAC and FBC. Okay, so basically, drawing the free body diagram is not just merely drawing something, but you have to know the purpose of drawing the free body diagram. You have to know what problem that you want to solve. Okay, for example, this problem yesterday we solved for this, and when we solve for this, you can see that what we draw is just the truck only the truck with the weight, with its own weight, and the load weight. Okay, we do not draw the ground anymore. Remember, we do not draw the ground anymore, because we want to solve only the truck. Okay, only the truck. So we do not draw the ground anymore. The ground, we represented the ground with the normal force at the wheel A and wheel B, like that. Okay, so you're supposed to know what problem that you want to solve and try to draw the free body diagram which can help you to solve the problem. Okay, so you have to draw the free body diagram based on the problem that you want to solve. Okay, next. This is the next problem that we want to solve. Okay, it's about pulley. Let us read the problem carefully first, and then we will solve this together. Okay, I want you guys to read the problem carefully, then try to understand the question that is asked in the problem. Okay, I believe you read the problem. Anyone here want to help me to try to solve this particular problem? Anyone? Ada yang mau membantu saya untuk mengerjakan permasalahan ini? Silakan. Okay, if no one wants to help me, then I will point out to somebody here. Okay. Marcellus Mario.
Yes.
Okay, I want you to help me to solve this problem. But first, I want you to tell me what is asked in this particular problem, Mario.
The tension T.
The tension T. Okay, calculate the tension T. Calculate the tension T over here. Okay, and in order to do that, what we have to do, Mario? In order to find T, what we supposed to do, Mario?
Draw free body diagram.
Draw the free body diagram. Okay, but in order to draw the free body diagram, as I told you before, we cannot draw the free body diagram just by drawing it. But you have to know the purpose of drawing the free body diagram. Okay, here is T, right? That's the thing that is asked. Okay, but I believe we will not be able to solve the free body diagram by just drawing the whole free body diagram. Okay, we have to isolate the problem one by one. From all of this, which one is the known value?
The weight.
The weight. Only the weight, right, Mario? Nothing else, right?
Yes.
Okay. So what do you think? What do you think that which free body diagram that we're supposed to draw?
The pulley.
Which pulley that we're supposed to draw first?
A.
Pulley A. Yes, correct. We're supposed to start with pulley A. And remember, okay, that there is a information here that you're supposed to not miss. Okay, its pulley is free to rotate about its bearing. What does it mean, Mario?
There is no restriction.
No rotation restriction, which means there is no friction, okay, in the pulley. Okay, Mario? So the pulley itself has no friction. So now let's draw the free body diagram of pulley A. What are the forces which is happening on the pulley A? Mario?
Weight and tension.
Weight. Okay, weight. Where am I supposed to put the weight?
In the center.
Yeah, in the center. Okay. 1000 lbf. What else?
Tension.
Tension. Where am I supposed to put the tension? Mario?
Maybe in the middle.
In the middle. Okay. Whenever you want to draw it, like the tension force here in the middle is already represented by the weight itself, Mario. So we don't have to draw the tension force in the middle anymore. Okay. So try to take a look at this and this. Those are ropes, right, Mario?
Yes.
Okay. So when we have ropes there, which means that we will have a tension, right?
Yes.
Okay. So at the sides of the pulley, we're supposed to have a tension, right? And when we talk about tension, the direction is supposed to be in tension, right?
Yes.
Okay. So what I supposed to draw here then? Okay. If I want to draw the tension force here and here, which direction that is supposed to go then? Hello?
Up.
Mario?
Up.
Up. Okay, yes, correct. It's going up. Okay. I will name this one as tension 1. I will name this one as tension 2. Okay, now from this particular free body diagram, how many knowns value that we have, Mario?
1,
1000 lbf. And how many unknowns value that we have?
2,
2, T1 and T2, right? Okay. Can we solve that? Can we solve the both of the unknowns, Mario?
still no.
Hmm?
No. Yes, yes, yes.
Yes, for this one, yes, you cannot solve it. Okay, then try to list out all the equations that you have here. Equilibrium
Sigma,
equation that you have for this particular free body diagram.
sigma Fy is 0.
Okay, sigma Fy equal to 0. What else?
Sigma moment 0.
Sigma moment 0. Sigma Fx equal to 0. Can we use it, Mario?
No.
Nope, because there is no horizontal forces, right? So we cannot use it. We have two equations here. We have two unknowns here. Can we solve it, Mario?
Yes.
Yep, we can solve it. Now try to solve it, Mario. Okay, try to solve it using sigma Fy first equal to 0. What will you have there?
T1 plus T2
Yeah, going up positive, T1 plus T2
minus 1000 is 0.
minus 1000 lbf is equal to 0. From this, we will get T1 plus T2 equal to 1000 lbf, right? Now, using sigma moment equal to 0, what will you have? What will you get?
T1 times radius
Okay. T1 times radius
minus T2 times radius
T2 times radius
is 0.
equal to 0, right? In this case, what will you get at the end?
T1 is equal to T2.
Correct. T1 is equal to T2. Then, can we find out the value of T1 and T2, Mario?
Yes.
Yep. Using this, right? Using this equation, we will be able to find out because T1 is equal to T2. So, okay. So, 2T1 equal to 1000 lbf, right? And because T1 is equal to T2, then T2 will be the same as T1. Okay, so from this equation, what we will get is T1 is equal to 500 lbf. T2 is the same, equal to 500 lbf. Correct, right? Mario?
Yes.
Okay, now we try to go to the other pulley then. If we already solve for T1 and T2, so which means that we solve for this particular tension and this particular tension, okay, which free body diagram, which pulley that we're supposed to go next, Mario?
Pulley B.
Pulley B, yes, correct, pulley B. Now let's draw pulley B. This this is pulley B. Okay, what force is acting on pulley B, Mario?
T2
T2, where?
in the center.
At the center. Which way is going to?
Down.
Down, correct. Okay, for some of you, maybe you are wondering why T2 is going down here. Remember, it's action and reaction. So if it's going up at pulley A, okay, it's supposed to be going down at pulley B. Okay, action and reaction. Okay. And remember, it's always tension. So at pulley B, it will pull the pulley B down like that. Okay. Now what else that we have, Mario?
Two tension.
Two tension. Which way both going?
Up.
Up, correct. So we will have it here and here. I will name this as I will name this as T3 and I will name this as T4. Okay. Now, T2 we already know the value, right? So T2 is equal to 500 lbf. How about T3 and T4, Mario?
Find using sigma Fy is 0.
The same as before, we don't have it. We don't have T3 and T4 yet. So, but we can solve it, right? Remember, in each free body diagram, we will have equilibrium equation. And in this free body diagram as well, we have two equilibrium equation, which is sigma Fy equal to 0 and sigma moment equal to 0. Correct, right, Mario?
Yes.
Yep. Using sigma Fy equal to 0, what will you have, Mario? What will you get?
T4 plus T3
Yeah, T3 plus T4.
minus T2.
Don't use T2 anymore because we know the value, right? So when you know the value, don't put it as a variable. So minus 500 lbf equal to
0.
0. Okay. Using this one as well, what we will get is T3 plus T4 equal to 500 lbf, right, Mario? And now,
Yes.
using the sigma moment, what will you get?
T4 times R.
T4 times R plus, minus, right?
Yes.
Minus T3 times R equal to 0. So what you will get there is T3 equal to T4. Okay, using this equation, you will get that the 2T3 is equal to 500 lbf. So T3 will be equal to 250 lbf and T4 will be equal to 250 lbf as well. Correct, right, Mario?
Yes.
Now you solve for this and this. What else that you need to solve then after this? Mario?
That T in policy.
Pulley C. So now, which free body diagram are we supposed to draw then?
Policy.
Pulley C. Okay. Let's go for pulley C then in that case. Okay. At pulley C here, what forces that we have, Mario?
Tension.
Tension from which one?
T4
T4. And which way is going?
down.
Down, correct. This one is T4. And we know already the value of 3T4, right? 250 lbf. What else that we have there?
T.
T. It's slanted. Yeah, this is the answer. T is slanted 30 degrees like this. T. Okay. It's not yet known. What else, Mario?
Reaction force.
Reaction force at C, okay, in the middle, okay, reaction force in the middle. And the constraint there is what type of constraint that you have there? That we have there? Hello, Mario. What type of question that we have here, Mario?
Not sure.
Not sure. What do you think? Is it a pin or is it a roller? Or is it something else?
Pin.
Pin, okay. Remember, when we have a pin joint, we're supposed to represent the pin as reaction force, right? But the reaction force is supposed to be in two directions, correct, right, Mario?
Yes.
Okay, so we're supposed to draw this as what then, Mario? The reaction force that we're supposed to put there is what and what?
Fx and Fy.
Correct. Yeah, I will name it as Cy and Cx. Okay, we have two reaction force over there. Okay, now the question there is find the magnitude of the total force on bearings and pulley C. So the total force which is happening to the pulley C is supposed to be stated as well, and T we supposed to find. So all of this we need to find out T, Cx, and Cy. All of those three we need to find out. Okay, now Mario, would you mind to list out all the equations that we have in order to solve for these three unknowns, Mario?
Sigma Fy is 0.
Yep, correct. Sigma Fy equal to 0. What else, Mario?
Sigma moment is 0.
Sigma moment is equal to 0. What else?
Sigma Fx is 0.
Yep. We have Fx, sigma Fx equal to 0 because there is a horizontal force there. Okay. So let's try to solve this then. Which one that you want to solve first then, Mario?
Sigma Fy.
Sigma Fy. Hello, Mario?
Yes.
Yep. Okay. I will give you a hint then. If you use sigma Fy later, you will have the sine component of T, and you will have a Cy as well then. So in one equation, you will have two unknowns, right? You will not be able to solve it directly. It's not necessary you always use this kind of way, but this kind of way will help you to ease the calculation. If you use sigma Fx equal to 0, there will be two unknowns as well in the equation. The cosine component of T and Cx. But if you use sigma moment at C in the middle, okay, there will be only one unknowns, T, because T4 is already known. So the best way is to use sigma moment first. Sigma moment at C equal to 0. Okay, Mario? Would you mind to execute sigma moment at C equal to 0, Mario?
T4 times R.
T4, we don't have T4 anymore because we have the value, right? So 250 lbf times R. What else that we have?
Minus T.
Minus T times R equal to 0. What will we get there, Mario?
T.
T equal to?
250.
250 lbf. Okay, we get the value of T. Now, in order to solve for Cx and Cy, which one that you want to solve first, Mario?
Sigma Fy.
Sigma Fy, okay. Sigma Fy equal to 0. What you will get there?
250.
250. You want to do it going up positive or going down positive?
Going down.
Going down positive. Okay then. 250 lbf. What else?
Minus T sin 30.
Minus T sin 30. T, we have the value as well.
250.
250 lbf sin 30 degrees. What else?
Minus CY.
Minus CY. Equal to 0. Okay. From this case, can you find out the value of CY, Mario?
Yes.
Yeah. What is the value of CY?
125.
Sorry?
125.
125. Sin 30 is half, right? Okay, correct. It's CY. Okay, now we are left with CX, right? What equation are we supposed to use in order to solve for CX?
Sigma fx is equal to 0.
Right. Sigma fx equal to 0. Okay. What you will get in order to what will you get in the equation? Mario?
250 cos 30.
200. Okay, going right positive then in the case. 250 lbf cos 30 degrees. What else?
Minus CX.
Minus CX equal to 0. So CX is 250 cos 30, right? What is the value of 250? What is the value of that? 250 cos 30.
216.5.
216.5 lbf. That's it. You solve all the things there. So the force working at C is CY and CX, and the tension there is supposed to be 250 lbf. Okay, do you get it, Mario? Supposed to be okay for you right now, right? Hello, Mario?
Yes.
Okay, good. Anyone here want to ask question about this? Okay, as usual, I will try to re-explain this in bahasa. So basically, bisa dilihat di sini ya, bahwa kita memiliki kasus puli seperti ini. Lalu bagaimana kita menyelesaikannya? Seperti yang saya sudah bilang sebelumnya, saat kita menyelesaikan suatu permasalahan, kita coba lihat terlebih dahulu urut-urutan penyelesaiannya harus seperti apa. Free body diagramnya, diagram benda bebasnya, seharusnya kita gambar sesuai dengan kasus yang ingin kita selesaikan. Nah, di kasus ini yang sudah diketahui terlebih dahulu itu adalah massa 1000 lbf di sana. Berat 1000 lbf di sana ya, di sini. Oke, ada berat 1000 lbf di sini. Nah, dari situ kita tahu bahwa kita harus menyelesaikan puli A terlebih dahulu. Lalu kita gambarkan diagram benda bebas puli A. Di sana ada T1, T2, dan juga 1000 lbf. Oke, kita bisa selesaikan T1 dan T2 dengan menggunakan persamaan ini. Tidak ada sigma fx sama dengan 0 karena tidak ada gaya horizontal. Dapat T1, T2, oke. Tegang tali di sini dan tegang tali sini dapat. Kita kemudian coba selesaikan puli yang di sini. Puli B. Oke, di sana ada T2, aksi reaksi ya, di sini dengan di sini. Itu aksi reaksi. Makanya kalau yang di sini ke atas, yang di sini ke bawah. Selain itu ada juga T3 dan juga T4. Kita bisa selesaikan T3 dan T4 dengan menggunakan sigma fx dan sigma moment. Sigma fy sama dengan 0 dan juga sigma moment sama dengan 0. Dapat T3 dan juga T4. Nah, kemudian dapat T3 dan juga T4, tegang tali di sini dan di sini dapat. Selanjutnya kita tinggal menyelesaikan puli yang terakhir untuk mendapatkan tegang tali di sini dan juga reaksi di C. Seperti ini. Ya, ada gaya reaksi di C karena di C itu pin. Ingat ya, di C itu pin. Saat kita membahas terkait dengan pin itu selalu akan ada gaya reaksi dua buah seperti ini, X dan Y. Lalu selain itu ada T4 arah ke bawah, aksi reaksi dengan yang ini. Dengan yang ini ya. Yang ini ke atas, di sini ke bawah. Lalu ada T di sana. Kita bisa selesaikan dengan 3 persamaan. Sigma Fx sama dengan 0, sigma Fy sama dengan 0, dan sigma momen sama dengan 0. Sekarang kita bisa pakai sigma momen. Sigma Fx sama dengan 0. Karena gaya horizontalnya ada di sana. Seperti itu. Okay, until this point, anyone want to ask question? Audrey Vanita, do you understand, Audrey?
Yes, sir.
Okay, good. The other Audrey Putri, do you understand? Okay. Hazel Herlambang, apakah dimengerti Hazel?
Mengerti, Pak.
Oke, sip. Raffi tadi ya, udah ya. Derin, apakah dimengerti Derin?
Mengerti, Pak.
Sip. Okay. In that case, I will continue with the other problem example. So, practice makes perfect. For this statics problem, okay, in order to solve a statics problem, practice makes perfect. That's why it is better for you to practice as much as possible. Okay, I will give you another problem example. Let's see this one. Oh yeah, this is the way actually I take the problem from the book, and actually the results is more or less the same as what our calculation was. Okay, this is another problem that we can try to solve. Let me check. I don't want to discuss the thing that I give you as a problem in your homework. Okay, no, this one is not part of your homework. We can try, but I want to try with this one first. I want to try with this one first. In order for you to be able to imagine if we have a problem like this, which is not explicitly shown about the free body diagram that we're supposed to draw, how we supposed to isolate the problem. Okay, this one. Yep, but later. I think I will start with this one. Okay. I will continue with this one. Now I will ask Audrey Putri. Hello, Audrey Putri.
Hello, sir.
Please try to understand the problem first. Everyone here, please try to understand the problem first. Then I will ask you to help me, okay, Audrey?
Okay.
Okay. And has any of you have any idea on what is asked in this particular problem? Audrey, do you understand about the problem?
We are asked to find like the largest weight drum.
Yep, the largest weight here. Okay, this one. Okay, the largest weight, which still be okay to be lifted by the floor crane. Okay. What do you think that we're supposed to do first, Audrey?
Maybe we can like isolate and make the free body diagram.
Okay, which free body diagram that we're supposed to draw, Audrey?
Maybe the one in C.
The one in C. In order for you to be able to draw it, I think I will move it to the sides. Okay. Which one, Audrey?
The one in point C.
The one point C. You mean this one?
Yeah.
But remember, right? This one, the one that is asked is the maximum weight that it can be lifted without causing the floor crane to roll over, to overturn. Okay. Try to imagine first, Audrey, and the rest of you guys as well. The condition of overturn condition is like, if the weight here is too heavy, what do you think will happen, Audrey?
The resultant force wouldn't be zero because
No. I mean, the physical condition that will happen to the whole crane. If the weight here is too heavy, what will happen to the crane?
The crane will be like pushed forward, like following
push
the
forward.
weight.
Remember, right? When we have a weight here, the force, okay, the force which is happening at the force that which is happening at the crane it will be going down, right? The weight will be pulling it down at point F here. Correct, right? Correct, Audrey.
Yes.
Okay, and try to imagine if the pulling force here is too much, the pulling force here going down there is too much, what will happen to the crane, Audrey?
Will be like somehow pulled towards the weight, like it will move.
The movement will be like what?
It's like it will like somehow fall forward, or
Yep, fall forward. Yes, it's correct. It will rotate like this, right?
yes.
Okay, and because it is pulled here at the front part of the crane, so it will roll forward. And when it roll forward, the center of rotation, which part of the crane will become the center of rotation, Audrey? Most likely, which part of the crane will be the center of rotation, Audrey?
Point F.
Point what?
Point F.
No, not point F. This one.
C.
B, right?
Try
to imagine, okay? If you pull it too much at point F, okay, the crane, it will rotate, and the center of rotation will be at point B, right? Correct or not, Audrey?
Wait, sir, I'm still confused. Like, what's the difference between point C and D?
Point C and D.
Yes.
Hey, point C is here, right? Point D is here. No, but the center of rotation later, when it roll forward, most likely will be here, Audrey. Do you get it, or not, Audrey?
Yes, yes.
Yeah. So if the weight here is too much, right? Most likely the crane will roll over, will overturn, and it will rotates forward because of the weight. And the center of rotation most likely will be here at B, based on our logic. Okay, and because of that as well, okay, when it overturn at A here, it will start to the it will start to going up like that. So I try to make you imagine on how it will rotates when it overturn. So because of the weight here is too much, okay, it's pulling it too much, then the part at A here will be going up. So, and the rotation will be centered at B like that. Do you get it, Audrey? That's what most likely happen when the force there, the weight there is too much. Do you get it, Audrey?
Yes, sir.
Yep.
Yes, sir.
Okay. Now, in order to know the maximum weight, right? What we supposed to know, or what we supposed to do, Audrey? Okay, I'm telling you right now, the free body diagram that we're supposed to draw is actually the whole crane with its weight as well. The only thing that we don't have to draw is just the ground, Audrey. Okay, so we have to draw everything because we are talking about the crane rolling over, the crane overturn. So we cannot just isolate on which part of on one part of the crane only. So we cannot do that. We have to draw the whole free body diagram of the crane. Okay, Audrey?
Yes, sir.
Okay, now let's draw it together. Okay. So we will have B here. What else? Going there. Yeah. Going there, and we have A here. Going up with the driver, everything. And then we go for the weight. Okay. And then it will be going down here with the weight. We can just draw it like this, right? Okay. We have to complete this with all the forces which is happening on the crane. What are the forces that which is happening on the crane, Audrey?
First, there's the weight on the
Which one?
Downward.
This one, you mean?
Yes.
Okay. And the force supposed to be going down, right?
Yes.
We call it as weight here. Okay, W. And what else?
And there's tension force.
Tension. You don't have to draw the tension because we draw the whole free body diagram.
Okay.
We don't have to draw the inside force. So, so it's like this. When we draw the free body diagram, right? The force that we're supposed to draw is just the external one and the weight only. So remember when we talk about this, okay, pulley, okay, the free body diagram, the system that we draw is just the pulley. That's why tension and all the tension force there will become external force. Okay. this one, okay, we talk about the truck. Okay, we draw the free body diagram of the truck, and the normal force from the wheel and the weight of the truck and the weight of the load will become the external force. It will become the force that we need to draw. Okay, so basically, when we talk about crane here, the system is quite close to this one, Audrey. So all the internal force which is happening at the crane, we do not have to draw it. So the tension here, we don't have to draw it because it become internal force. And then the this part as well, we don't have to draw it because it becomes an internal force. Okay, Audrey. So now try to imagine that we have a crane, only the external part of the crane, and we don't care about all the things that happen internally. Okay, Audrey. So we only draw the external force and the weight of the crane only. Okay. Okay. Beside the weight here, what else that we have there as external force and weight? Remember, here we have center of gravity, right? Center of gravity, and it is known that the weight of the crane with the driver is 2,400. Sorry, 2,500, right? Okay, so it's supposed to be going down. Yeah, 2,500 lbf. Okay, so all the weight are there. What else there that we're supposed to draw as external force, Audrey? At A and at B, there is a wheel, right? There are wheels, right?
Yes.
On the wheels, normally we will have what, Audrey?
Is it friction force?
Yeah, reaction force. The reaction force in the shape of normal force, okay?
Yes.
So we will have AY and BY here. Okay, Audrey?
Yes, sir.
Now we have all the forces working on the crane, right? Now try to list out all the unknowns and knowns, Audrey. Which part of it is our unknowns, Audrey? The W here, do we have the value, Audrey?
W, yes.
No, no, we don't have it because that's the one that is us, right? BY here, do we
Yes.
have the value?
No.
No as well. AY here, do we have the value?
No.
Let's go for it after this, okay? But based on this, we have three unknowns, okay? It looks like we have three unknowns. How many equations that we have, Audrey?
First, we can have the resultant of the y.
Okay, sigma Fy equal to 0. What else?
Then sigma m.
Sigma moment equal to 0. What else? Can we use sigma Fx equal to 0? No, because there is no horizontal forces, right?
Yes.
So we cannot use this. So in this case, we only have three. We only have a two equation, right?
Yes.
Okay, with three unknowns.
Yes.
Okay, but try to take a look again. Is it really three unknowns or not? Okay, Audrey, I want you to point out. I want you to point one of your friends which you think can help you to solve for this problem? Who, Audrey?
Maybe William Nathan, sir.
William. Okay, William. But you don't go anywhere, okay, Audrey? Because still this one is your problem. William.
Yes, sir.
Okay, William, Audrey asked you to help her to solve for this problem. Is it really we have 3 unknowns, William? In this case, William. Hello?
Yes. Wait a minute, sir.
Or anyone else in the class can tell me which is it really that we have 3 unknowns or we have less than that? Because remember, we only have 2 equations here. Please.
We can make one of them center of rotation, sir.
So one of them as a center of rotation, yes, as I told you before, right? B will become the center of rotation, Aurelia, right? B will become the center of rotation. When B is the center of rotation and the weight is close to the maximum, what will happen to A?
AY will be equal to the weight.
Wait.
No. Why not will become, okay, when it's close to rotating, when it's close to overturn, okay, AY will close to 0. Because if AY is, if AY, the value of AY is negative, right? Then it will start overturn. It will overturn for sure. But the limiting condition is AY is close to 0. Do you get it? Because we want it to make sure, we want to find out the weight, which the maximum weights, which the crane is not yet to overturn, right? In that case, we have to make sure that AY here is as small as possible and close to 0. Because try to think about it. Okay, if you make it as sigma moment at B, okay, sigma moment at B, okay, whatever value that you have to, whatever value you give to W, okay, whenever the W is going up, whenever the W is getting bigger and bigger, the value of AY will be getting smaller and smaller. And there is one limit condition before it overturn, okay, AY is close to 0. Do you get it, William? Do you get it, Aurelia?
Yes, sir.
How about you, Audrey?
Yes, sir.
Yes, sir.
So actually, the limiting condition there is, because I told you from the beginning, the center of rotation will become By, because when it rotates, B, not By, B will become the center of rotation. When it rotates, it will, the center of rotation will happen at B, okay? And because of that, the limiting condition will be at AY here, okay? The limiting condition is AY, okay? AY is close to 0. So if you make AY equal to 0, then what we will have is the maximum W. So in order to calculate for the maximum W, then what we're supposed to do? Just set AY equal to 0. As simple as that. So I set AY equal to 0. There is no AY there. Then in that case, I will set the W as the maximum W. Okay. Okay, Audrey? before we solve for this problem, okay, before we solve for this problem, anyone here want to ask the problem? We want to ask about this. Still not yet understanding about the problem. Still not yet understand about the thing that I just explained. Please let me know about it. Saya coba jelaskan dalam bahasa Indonesia ya. Jadi ini kasusnya, kasus script. Kita harus gambarkan secara keseluruhan. Nah, kasusnya itu kita harus cari tahu besar W yang besar W paling maksimum. Besar width di sana W itu yang paling maksimum. Sehingga sampai batasan di mana si screen itu hampir overturn. Ya. Tapi masih belum overturn. Masih belum guling gitu ya, mengguling ke depan gitu ya. Nah, bisa dilihat kalau misalkan dia guling ke depan, overturn gitu ya, center of rotation-nya akan terjadi pada titik B. Oke, pusat perputarannya akan terjadi pada titik B di sini. Dia akan bergerak ke depan, muter ke depan, center of rotation-nya akan terjadi pada titik B. Nah, kalau kita hitung-hitung ya, center of rotation-nya di B, sigma moment di B, saat saya naikkan nilai W, nilai A ini akan semakin mengecil, pasti. AY ini akan semakin mengecil. Sampai suatu saat AY nilainya 0, W ini nilainya akan maksimum. Kalau kalian tingkatkan lagi dari situ, dia pasti akan muter. Jadi batasannya, batasan kondisi batasnya itu adalah nilai AY ini mendekati 0. Nilai AY di sini mendekati 0 untuk bisa si W di sini maksimum. Oke, sampai di sini apakah ada pertanyaan? Silakan. Raka, apakah dipahami Raka?
Bisa dipahami, Pak.
Diva, gimana Diva?
Bisa.
Okay. Now, I will ask Audrey again. Please help me to calculate the maximum weight then, Audrey. Now, you know the condition already, right? No?
Yes, yes.
Okay, so AY is equal to 0. So basically now, this one, right? AY is equal to 0. So basically, how many unknowns that we have right now, Audrey?
2, sir.
Only 2, right? By and W. And we have 2 equations as well, sigma Fy equal to 0 and sigma moment equal to 0. Can we solve for this, Audrey?
Yes.
Yes, we can solve for this. Okay. Because the By is not passed, then I want you to just use sigma moment at point B equal to 0 to solve for W. Okay. What is if I want to calculate for sigma moment at B, what will I get there, Audrey?
Sorry, sir, can you repeat the question?
I want to calculate for W, right? The maximum W. We know that the maximum W will happen when AY is equal to 0. Now, in order to get the maximum W, I want to calculate sigma moment at P equal to 0. Okay, sigma moment at P equal to 0. Okay, so I want you to calculate for that particular equation using that particular equation, sigma moment at B equal to 0. So what will you get there?
Is it 2,500 LB multiplied by 8.4 plus 2.2 minus
2.2, sorry. 2,500 multiplied by 8.4 feet plus 2.2. 2.2 or 1.4?
Oh yeah, 1.4.
1.4, yes. Okay, so you make it as counterclockwise positive. Okay, so 2,500 LBF multiplied by 9.8. Okay, then in that case 9.8 feet. Okay, counterclockwise positive. And what else? There. From AY, will there any moment because of AY? Audrey?
No,
No, because AY is equal to 0. What else then?
and the weight of the
From W,
Drum.
yes.
Yes.
Now the problem is you have to find out the distance there, right? What is the distance
Yes.
there? The horizontal distance there. From here to here. From B to F there, what is the horizontal distance? How to get there, Audrey? It's supposed to be minus W multiplied by that horizontal distance, right? Remember the angle 30 degrees there, Audrey.
Yes. We use cosine,
Yeah, we can use cosine, yes, correct.
so it became 15 feet times cosine 30.
Sorry?
We multiply 15 feet by cosine 30.
Okay. So cosine 30 multiplied by how much?
15 feet.
15, yes, correct. Because we will get this, right? So 15
Yes.
cosine 30, this one is 15 cosine 30 degrees. Okay. In order to get this x, then you have to minus 50. You have to deduct 15 cosine 30 with 8.4, like that. You mean?
Yes.
Okay, correct. Then what is the value then? (15 cosine 30 minus 8.4. What is the value then?
It's 4.59.
4.59 feet. Okay, equal to 0. Okay, so this is your this is the equation of sigma moment P equal to 0, right? From this, you will be able to get W, right, Audrey?
Yes.
Okay, what is the value of W then?
It's 5,337.69.
5,300
and 37.69.
point 69 LBF. Okay,
Yeah.
thank you very much, Audrey. So that's the way to calculate for the maximum W. Okay, so whenever you have this kind of problem, impending motion, okay, just before the motion starts to happen, sometimes what you need to maximize the force is by zeroing the others. In this case, it's impending motion as well. Before it starts to overturn, okay, in order to make the W to the maximum value, what we have to do is to zero the normal force at A, like that. Okay, and this kind of problem is quite common in statics. So you will face this kind of problem quite frequently. Okay, thank you, Audrey. Okay, this one, what else that there are several problems like this that we can solve. Okay, some of those I will put it in your homework. Okay. This one, I believe I will explain this in the next class. And because you will have some of you will have a experiment class after this, then I don't think that I should prolong the class anymore. I think for today's class is just I will dismiss today's class. Okay, And don't forget to check your EduNext for homework, and the due date for the homework will be Thursday next week at 10 in the morning. Okay, so please check your EduNext. The problem will be posted by my assistant there. Okay, I think that's all for today. Thank you very much for listening. Don't forget to mark your attendance. Okay, I think that's all. Thank you very much. Bye.
Thank you, sir.
Yep.
Thank you,
Thank you.
sir.
Thank you.
Thank you, sir.
Sir.
Sir.